Professor, Department of Marine Engineering, Pearson College of Engineering and Technology, Tirunelveli. I am going to present about bimetallic joints of aluminum copper produced by diffusion bonding technique. Okay, first we must understand what is diffusion bonding. Diffusion bonding is a solid state metal joining process. Solid state metal joining process. But in the conventional welding, the metals are melted and joints are applied. But here, in the diffusion bonding, the joints are applied in the solid state. Here, in the diffusion bonding, there is no need a welding rod and a solidification cracks. Okay. Next, what are the problems of joining up bimetallic by using conventional welding technique? By using conventional welding technique, the difference of physical properties and the difference of mechanical properties such as strength, hardness, toughness, and the differences in metallurgical properties are different. By the different, the joining of bimetals by using conventional welding techniques is not possible. That's why the diffusion bonding technique is chosen. Various diffusion bonding techniques are available. One is a friction stir welding process, another one is explosive welding, third one is diffusion bonding. In the friction welding process, the edge of the metals are welded. So here in the diffusion bonding technique, the solid surface of the metals are bonded. So here another one is the explosive welding. The explosive welding is suitable for a huge huge size of the component. Okay, here that's why we are going to choose the diffusion bonding technique here. Diffusion bonding is a process that produces solid cells collisions between two material through the application of pressure, temperature below the melting point of the material to be joined. The diffusion bonding consists of three parameters such as bonding pressure, bonding temperature, holding time. Bonding pressure should be high enough to ensure a tight contact between the joint surfaces. If the pressure is less, the metals cannot be fixed in tightly, so the diffusion takes place between the surfaces very less. If high pressure is given, the edge of the metals bulge. So suitable pressure should be applied when the diffusion bonding is going on. Another parameter is bonding temperature. The bonding temperature generally to 0.52, that is a 50% to 80% of melting point of the metals. Next parameter is the holding time. The holding time should be enough. If the holding time is higher than the sufficient time, the metals are melted. If the holding time is less, the diffusion rate is very less. This will lead to affect the quality of the bonds. The initial part here, look at this diagram. This process here, this diagram explains the process mechanism of diffusion bonding. Here look at this diagram. Here the initial point of contact showing the residual oxide and the contaminant layer. Then yielding and grip, it reduces the void. Look at this here. Here the voids are higher. Here you can see the voids is minimizing. The voids is minimizing here and the thin contaminant layer. The final yielding and grip, some voids remain with a very thin contaminant layer. Continued, if the process continued, vacancy diffusion, eliminate the oxide layer, leaving a few small voids. Finally, the blending is completed. So the final bonding is completed. The diffusion bonding procedure. Here we are using aluminum copper specimens which were prepared by using powder metallurgy technique. The thickness of aluminum was 5 mm and copper was 3 mm. These metals are polished and chemically treated. Specimen were stacked. The specimen were heated up to the bonding temperature by induction furnace, and the heating rate of furnace was 10 degrees Celsius per minute. The required pressure was simultaneously applied to the certain time. Thus the bonding was completed, and then bonding chambers are cooled to the room temperature before removal from the chamber of diffusion bonding machines. Okay, for this procedure, the joints are applied. Look at here, this is a die setup. Say bottom plate, this is a top plate. Okay, this metals, the specimens were kept between the top plate and the bottom plate. Then, after fixing the metals, that is aluminum copper, it is kept in the vacuum chamber. It is kept in the vacuum chamber. Look at this diagram. This is a diffusion bonding setup. This is a load cell by which the pressure is applied, the load is applied. Here this is a induction furnace by which the temperature is applied. Here this is a diffusion bonding chamber. The setup of die is kept in the diffusion bonding chamber. Through the load cell, the load is applied, by which finally the metals are joined by this process. This is an example of some of the fabricated diffusion bonding of copper aluminum. Here, effect of bonding temperature on shear strength and bonding strength. So here the y-axis indicates shear strength and bonding strength. The x-axis indicates bonding temperature. Okay, here this is a brown color shear strength. This is bonding strength. The shear strength is evaluated by using lap shear tensile test, and bonding strength is evaluated by using RAM tensile test. Okay, now look at the diagram. Initially at the 250 degrees Celsius, the shear strength and bonding strength are very less. When the temperature increases, the bonding strength and the shear strength increase. Okay. When the temperature increases up to 350 degrees Celsius, the shear strength bonding strength is increased. After the temperature of 350 degrees Celsius, the shear strength and bonding strength are reducing. And again at the 450 degrees Celsius, these two strength are again reduced because this is a optimum temperature. 350 degrees Celsius is the optimum temperature. At this temperature, the diffusion layer thickness is optimum. Here when the temperature, bonding temperature increases, the diffusion layer increases. Diffusion layer, look at this diagram. This is a diffusion layer thickness. Okay. When the temperature increases, the diffusion layer thickness increased. So we can get the higher strength when the diffusion layer thickness is optimal. Okay, here the bonding temperature. The bonding temperature increases the diffusion of atoms. The diffusion of atom increases, by which the metal surface of the contact will be optimum. The effect of bonding temperature and diffusion layer thickness. So here, look at this diagram. The x-axis indicates bonding temperature. In the y-axis, the diffusion layer thickness indicates. When the temperature increases, the diffusion layer thickness also increases. Because when the temperature increases, it is proportionally to the diffusion bonding rate. Whenever the temperature increases, the diffusion layer thickness also increases. The effect of bonding temperature on the interface hardness. Okay, here the temperature depends upon the interface hardness depends upon the bonding temperature. The interface hardness, that is a hardness which occurs between the metals. Look at here. Here this is a diffusion layer thickness. The interface, this is called the interface. Here, the interface depends upon the bonding temperature. When the temperature increases, the interface hardness will be higher. Next, another parameter. The effect of another parameter is bonding time. Here, the bonding time is on x-axis. The the shear strength and bonding strength are in the y-axis. So here the bonding time, when the bonding time is at 15 minutes, the shear strength and bonding strength are less. When the bonding time is increased, that is up to at 30 minutes, the strength are increased. At 45 minutes, the strength are increased. At 60 minutes, the shear strength and bonding strength are increased. After which, here at 75 minutes, these strength are reduced, and again at 90 minutes, these shear strength and the bonding strength are decreased. Because here at 60 minutes, the shear strength and bonding strength are higher. Since the diffusion layer thickness is optimum, at this optimum diffusion layer thickness, we can get the higher shear strength and bonding strength. The effect of bonding time on diffusion layer thickness. The diffusion layer thickness depends upon the holding time. Here at 15 minutes, the diffusion layer thickness is less. And the 30 minutes, the diffusion layer thickness linearly increased. So the diffusion layer thickness depends upon the bonding time. Whenever the bonding time increases, the diffusion layer thickness also increases. The effect of bonding time on interface hardness. The interface hardness also depends on the holding time. Here, the interface hardness is increased with respect to holding time. The time at 15 minutes, the interface hardness will less. Whenever the holding time increases, the the interface hardness also increases. Effect of bonding pressure on diffusion layer thickness. Look at this diagram. The pressure is mentioned in the x-axis. The diffusion layer thickness is mentioned, that is a micrometer, in the y-axis. When the pressure is increased, the diffusion layer thickness also increase. Because when the pressure is increased, the tight contact will occur between the contact surface of the metals, by which the diffusion rate of atoms and the expansions of boundary will be increased, by which the diffusion layer thickness increases. Effect of bonding time on shear strength and bonding strength. Here bonding time is mentioned in the x-axis, the strength are mentioned in the y-axis. So here at the bonding time 45 minutes, initially the bonding strength and shear strength are less. When the bonding time increases, the strength, these two strength are increased. Okay. Up to 60 minutes, these two strengths are increased, after which the strengths are reduced. Because when the bonding time is higher, the diffusion layer thickness will be increased by the diffusion of atoms. Whenever the diffusion layer thickness increased, the shear strength and bonding strength are very less because of the intermetallic components. The application of diffusion bonding. Most of the diffusion bonding are used in the manufacturing of electrical and electronic devices, heat exchangers, automotive industry, aerospace industry, in renewable energy systems. Electrical and electronic devices, that is a bus bar, are manufactured. The heat exchanger, by using diffusion bonding, the heat exchanger are manufactured. Mostly in the automotive industry nowadays, the diffusion bonding is applied. Aerospace, manufacturing the wings of the helicopter wing are manufactured by using the diffusion bonding techniques. Renewable energy, that is solar, windmill, are manufactured by using diffusion bonding techniques. Okay, thank you.